In chemistry, units, which are the standard quantities, are used to specify measurements, and the units are extremely critical. If you get them wrong, the consequences can be disastrous. The two most common unit systems are the English system, which is used in the United States, and the metric system, which is used in most of the rest of the world. Scientists use the International System of Units, or SI, which is based on the metric system. Now, the table that you see here shows the standard SI base units. So for now, we're going to focus on length, mass, temperature, time, and we will look at the amount of substance in the following chapters. You will also see that we use lots of prefixes in the metric system for quantities that are either too big or too small. The prefixes that you see on this table, I need you to memorize them. What you memorize is the prefix name, the symbol, and the numerical value. What is going to be more helpful would be the power of 10 equivalent for these numerical values. So the first metric system, or the SI unit that we're going to look at, is meter for the measurement of the length. The meter is slightly longer than a yard. The unit that we use for meter now is defined as the distance light travels through a vacuum in a certain period of time. Scientists commonly deal with a wide range of lengths and distances, and it's very important for us to learn how to do the measurements and how to also convert in between the prefixes using the unit of meter. So what you see here on this slide is how the prefixes are used. So next to each unit, you usually see prefixes. So meter is the unit, and centi is a prefix. Or for example, here meter is the unit, and milli is the prefix. So one of the important conversions for the measurement of length is the conversion between inch and centimeter, because in the United States we're more used to the inch. That's the common unit, but in the SI system we use meter. Now the conversion between inch and centimeter is given to you. 1 inch is 2.54 centimeter. So in science, it is often necessary to convert a given result from one system of units to another. The method that we're going to use in order to do the unit conversion is called dimensional analysis. So I'm going to show you different examples of dimensional analysis. So basically, what you want to do for dimensional analysis, you want to go from unit 1, which is the given unit, times a conversion factor, which gives you unit 2, and unit 2 is basically the desired unit. So unit 1, it's what's given or what you have, and unit 2 is the desired unit. So to solve problems, to do unit conversions, we need to identify what unit 1 and unit 2 are, and we need to write a conversion factor. Now, the best way to start writing conversion factors is by starting from the equality. For example, here, 1 kilometer equals to 1,000 meter. So to convert in between kilometers and meters, we're going to use this equality. based on this equality, we can write our conversion factors in two ways. Either 1 kilometer is 1,000 meter, or each 1,000 meter is 1 kilometer. These are the two possible conversion factors that we could use in order to convert in between kilometers and meters. Now, based on what's given to us, what we're solving for, we're going to choose one of these conversion factors to convert in between the unit of kilometers and meters. So let's look at an example here. You want to convert 215 centimeters to meters. So what's given to us is centimeter, and we're trying to find meters. So unit 1 is centimeter. Our desired unit is meters. So remember, for dimensional analysis, we want unit 1 times a conversion factor should give us unit 2. Now unit 1 and unit 2, we identified it. Now what we need to find is a conversion factor that allows us to convert in between meter and centimeter. So in order to write the conversion factor, we always start with the equality. I know that 1 meter is 100 centimeter. Now based on this equality, I can write two possible conversion factors. So each meter is 100 centimeter, or each 100 centimeter is 1 meter. Now starting with what's given to us, 215 centimeter, I'm going to use a conversion factor in which centimeter and centimeter cancel out, and you want to end up with meters. So I'm going to choose the first one, 1 meter, 100 centimeter. So centimeter and centimeter cancel out, and you're going to end up with meters. Now let's look at another example. You want to know how many micrometers are in 0.03 meters. So from meters, we want to go to micrometers. Now let's think and remember the relationship between meter and micrometer. We know that each meter is 10 to the 6 micrometer. So our two possible conversion factors are going to be 1 meter, 10 to the 6 micrometers, or each 10 to the 6 micrometer is 1 meter. Now starting with what's given to us, which is 0.03 meters, you want to choose the conversion factor in which meter and meter cancel out, and you want to end up with only micrometer. So I'm going to choose the second one. Now meter and meter cancel out, and you end up with micrometers. Now this number could also be written as this. Now when doing conversions, keep in mind that in terms of significant figures, you want to look at your quantity for significant figures. Conversion factors don't count for significant figures because they are constant. They have infinite number of significant figures. So you always want to look at the quantity that's given to you. So 0.03 meter has only one significant figure, and you want your answer to also have only one significant figure. Now, dimensional analysis and converting units can oftentimes include multiple steps. So for example, let's say you want to convert from days to seconds. I don't know any conversion factor that allows me to go directly from days to second. So from here, you're gonna come up with a solution map and see based on the knowledge that you have how you can go from days to second. So one way this can be done is from days going to hours, hours to minutes, and minutes to second. So basically 3 different steps. So we know that one day is 24 hours. This is a step 1. Step 2, you convert hours to minutes. There are 60 minutes in each hour. And last step, you convert minutes to seconds. Now let's look at another example. How many cubic centimeter are in a box that measures 2.20 times 4.00 times 6.00 inches? So in order to find the volume of this box, what we can do is first find the volume in inches. So 2.20 inch times 4 inch times 6 inch, which is going to be 52.8 cubic inches. Now what we're trying to do is to go from cubic inches to cubic centimeter. This is our equality. We know that each inch equals to 2.54 centimeter. So let's start with 52.8 cubic inches. Now we know that each inch is 2.54 centimeter. Now by using this conversion factor only once, 1 inch and 1 inch cancel out. But in order to cancel out all 3 inches here, we have to use this conversion factor 3 times. Now 1, 2, 3 cancels out, and 1, 2, 3, your unit is going to be cubic centimeter here. This is one way of doing this. The other way you could do this was starting from 52.8 cubic inches. You could say that each inch is 2.54 centimeter, and you cube it right here. But keep in mind that when you cube this, everything inside the parentheses should be cubed. So 2.54 should be cubed. This is going to be cubic centimeter. 1 is being cubed, and inches is being cubed too. So the answer should still be the same. So another important units of measurement for us is the mass. So the unit of mass, the SI unit of mass is in kilograms, but of course we can always use prefixes with the units of gram too. For example, here this kilogram, gram is basically our unit, kilo is the prefix. Or let's say centigram, again gram is our unit and centi is the prefix. So again, keep in mind that with each unit can be accompanied by a prefix. Now let's look at a couple of examples for the unit measurements of mass for prefixes. So you want to convert 343 grams to kilograms. So from grams, we want to go to kilogram. So we know that each kilogram is 1,000 grams. This is the equality. We're going to write our conversion factor based on this equality. So starting from 343 grams, we know that each kilogram is 1,000 grams. So grams and grams cancel out. So this is going to be 343 times 10 to the negative 3 kilograms. You could write this in scientific notations or any other format too. So the format of your final answer doesn't really matter. What's important is the number of significant figures. So let's look at another example. You want to know how many centigrams are in 0.12 kilograms. So from kilograms here, we want to go to centigrams. Now here we're basically converting in between two prefixes. So sometimes it's not easy to know the conversion factor in between the two prefixes. So what helps is to convert first to the unit without any prefixes and then do another conversion. So here I'm going to convert from kilograms to grams, which doesn't have any prefixes, and then from grams to centigram. So let's start. You have 0.12 kilograms. Step 1, you want to convert this to grams. You know that each kilogram is 1000 grams. And then to convert in between grams and centigrams, you know that each gram is 100 centigrams. So that gives you 0.12 times 10 to the 5 centigrams, or you could write this as 1.2 times 10 to the 4th centigrams. So another important measurement for us is going to be the volume. Volume is the amount of space occupied by the matter. So for the volume of solids, our unit is going to be cubic meter. And for liquids, the volume is either in liters or milliliters. So the different devices or glassware you see in this slide are the glassware that can be used in order to measure the volume. Now, depending on what we need to do and how precise we want our measurement to be, we can use any of these glassware to measure the volume. Now, for volume, oftentimes we use it in milliliters because we use a smaller scale in the lab. So these are some common volume relationship. Each liter is 1000 milliliter, and one very useful one is 1 millimeter equals to 1 cubic centimeter. So memorize this. 1 milliliter is 1 cubic centimeter. So here is an example to convert in between liters and milliliters. You want to convert 0.345 liters to milliliters. You know that each liter is 1000 milliliters. So liter and liter cancel out and you end up with milliliters. So let's do another example here. You want to know how many milliliters are in a cube with sides measuring 13.1 inches each. So milliliters is the unit of volume. So we have to find the volume of the cube first and then convert it to milliliters. So to find the volume of the cube, that's 13.1 times 13.1 inches. So a better way to write this is, so for the volume of the box, 13.1 inch times 13.1 inch times 13.1 inch, and this answer is going to be in cubic. So the answer is going to be 2.25 times 10 to the 3 cubic inches. Now, from cubic inches, we need to convert to cubic centimeter, and then from cubic centimeter, we convert to milliliters. So from cubic inches, we convert to cubic centimeter, and then from cubic centimeter to milliliters. So 2.25 times 10 to the 3 cubic inches. Each inch is 2.54 centimeter. And then we know that each cubic centimeter is 1 milliliter. So the answer is 3.69 times 10 to the 4 milliliters. So let's look at temperature and the units of temperature. So thermal energy is defined as a form of energy that involves the motion of small particles of matter. Temperature is the measure of the intensity of the thermal energy. So the higher the thermal energy, the higher the temperature. The lower the thermal energy, the lower the temperature. Also, we define heat as flow of energy due to a temperature difference, and heat always flows from hot to cold. Now, this SI unit of temperature is in Kelvin, and the device that we use in order to measure the temperature is the thermometer. So this is conversion, the formula to convert in between Kelvin and degrees Celsius, Fahrenheit, and degrees Celsius to memorize the unit conversion in between Kelvin and degree Celsius. So Kelvin is the temperature in degrees Celsius plus 273.15. And also keep in mind that from Fahrenheit, you can just convert to degrees Celsius based on this formula. So we can go from Fahrenheit directly to Kelvin. You would need to go from Fahrenheit to Celsius and then from Celsius to Kelvin. Here is an example of temperature to convert 723 degrees Celsius in Kelvin. You just plug it into the formula that gives you 996 K, and for Fahrenheit that would be 1333 Fahrenheit. Now a couple of things to pay attention to here. First of all, for Kelvin it's written in caps and it doesn't have the little small circle here which represents degree. So for Fahrenheit and Celsius we read it as degree Celsius, degree Fahrenheit, but for Kelvin it's just Kelvin. So here is another example. You want to know the temperature of 98.6 degree Fahrenheit to Celsius. So from Fahrenheit we're going to Celsius. You just plug it into the equation here and it's going to be 37 degree Celsius. So let's look at density now. Since we've learned the units of measurement and some SI units, we're going to look at the density, which is the ratio of mass over volume. Density is a physical property of a substance. The unit of density for solids is in gram per cubic centimeter, and for liquids is gram per milliliter. For gases, the unit of density is grams per liter. So density is a very important concept in chemistry. It's one of those measurements that you can do very easily in any chemistry lab to identify your unknown. Now obviously density is cannot be the only characterization technique used, but it's a good start to narrow down your search and see what type of unknown you have. So let's look at a couple of examples here. You want to calculate the density of a substance if 323 grams occupy a volume of 53 milliliters. So density is mass over volume. So mass is in 323 grams and volume is 53 milliliters. So 323 divided by 53, which is 6.09 grams per milliliter. Let's look at another example. The density of gold is 19.3 grams per milliliter. You want to know the volume of 25 grams of gold. So for gold, density is given to us, which is 19.3 grams per milliliter. Mass is also given to us, which is 25 grams. You want to find the volume. So let's look at the formula of density. Density is mass over volume. You want to isolate volume here. So first step, just assume that there is a 1 here and you do cross multiply. Therefore, density times V equals to mass. Now, in order to isolate volume, you divide both sides by V. Or we're trying to isolate V, so we divide both sides by density, because we're trying to isolate volume. So you divide both sides by D, density. Now volume equals to mass over density. So volume equals to mass, which is 25 grams, divided by density, 9.3 grams per milliliter, which is going to be, so 25 divided by 19.3, which is going to be 1.26 milliliter. Now let's look at another example. The mass, you want to find the mass of 1.50 milliliters of ethyl alcohol, where density is 0.789. So density is mass over volume. We're trying to find the mass, so you're just gonna do cross multiply. So mass is going to be density times volume. So density is so the volume is 1.50 milliliters and density is 0.789 grams per milliliter. So milliliter and milliliter cancel out. You end up with the mass. So we learned about the metric system, the important units of metric system. We learned dimensional analysis as a method in order to convert in between the units or prefixes, and we also look at the units of measurement for temperature, volume, and we talked about density, which is a physical property.